Today's topic is 18 FT 305, that is basics of fiber, yarn and fabric manufacturing, and we are at unit 2, that is the mechanical and comfort properties. Now in the lesson 3 there are subjects like humidity, which is there with absolute humidity, relative humidity, moisture content, moisture regain, and then the factors which are influencing the moisture regain. We will also see here the conditioning of fibers, that is the static electricity generation, and also how in different processes the static electricity will hamper the processes in the spinning and weaving. That means that yarn is rotating or is passing through some guides. That time static electricity generation is there, and this is all dependent upon the fiber characteristics. So this particular lesson will talk about the moisture basically and the effect of such moisture on the properties of the fiber and its performance while it is running through different machines. Let us see now how this humidity can be looked into. Now, as we all know that humidity or the generation of the humidity, how it generates the humidity, and due to this effect of the sunshine, the surface is getting heated, and then there will be little bit of water cycle or the water vapor will be there, and then that water vapor, when there is increase in the weight of that one, then rain or snow it will come. So that is the humidity. Now basically it talks about the amount of water vapor in the air. So that talks about the humidity, and a lot of water vapor in the air, the humidity will be high. So this is very common, that we have already explained. So higher the humidity, the wetter it feels outside. So these are the features of more humidity. Now what is the meaning of absolute humidity? Now absolute humidity, as it talks about, is the density of the water in the air. It is usually measured in grams of water vapor per cubic meter of air. Okay, so that is called the absolute humidity. So in other words, it is mass of water vapor per unit volume of air. Now what is relative humidity? The relative humidity is nothing but a ratio of the actual amount of water in the air compared to how much it could hold. So that is the relative humidity. It talks about how much moisture is in the air relative to how much it can hold. So at different temperature you can see that relative humidity, how it differs, starting from 10 degrees centigrade, from 20 degrees centigrade and 30 degrees centigrade. So how with the temperature the relative humidity varies, it is shown here. So on the weather reports, humidity is usually explained as the relative humidity. So that is the conventions of expressing humidity. Now what about the moisture content? Now moisture content is actually governed by some formula. As you can see, the moisture content M is equal to W by W plus D into 100, and moisture regain, that is expressed in R, is equal to W by D into 100. Now here if we see the moisture content M, how it is expressed, so D means oven dry weight of a material, and weight of water in the material is expressed by W. So formula talks about W and D. So one is W divided by W plus D, and moisture regain is W divided by D. So moisture regain and moisture content, what is the effect of these on different fibers? Now if you see the examples of cotton, then the moisture regain is 8.5% and the moisture content is 7.83%. Similarly, the bast fiber like flax and hemp, moisture regain percentage is 12 and moisture content percentage is 10.7. Similarly, different fiber is having the different moisture regain and moisture content properties, because moisture content means that inherently the fiber contains certain amount of moisture, and moisture regain means how it attracts the moisture from the standard atmosphere. So you are talking about flax and hemp. Similarly, jute fiber also, high amount of moisture regain is there, 13.75%, and moisture content percentage is 12.1%. Silk also 11% is the moisture regain and moisture content is 9.91. Viscose rayon 11% is the moisture regain and 9.91 is the moisture content. Similarly, the rayon, worsted yarn, woolen yarn, they are having the different moisture regain and moisture content properties. Nylon on the other hand is very low moisture regain, 4.2, and moisture content is 3.78. So these are in a nutshell different textile fibers, how the moisture regain and moisture content varies. Now when you are talking about the moisture, one must admit that moisture will depend upon the atmosphere, atmospheric conditions. So what do you mean by atmospheric conditions? We talk about the relative humidity, and 65% plus minus 2% is the standard, and temperature in the cold countries, that is the temperate zone, 20 degrees centigrade plus minus 2 degrees centigrade, and in tropical countries 27 degrees centigrade plus minus 2 degree centigrade. So that is the standard temperature and humidity. Now any kind of experimentation with the fiber, what you do, or the testing what you do, or processing, so this testing atmosphere plays an important role, that is the standard atmospheric conditions. Now comes the factors which are influencing the moisture regain. What are those factors? Let us see. Now those factors which actually affecting the regain of textile material, so those are the relative humidity, time, temperature, and also the previous history of the sample. This is very, very important. The sample, what is the previous history of its production? So that plays an important role. So these are the factors which are influencing the moisture regain properties of a fiber or textile material. As you can see that different regain percentage and relative humidity, how it varies. So as we increase the relative humidity percentage, you can see the regain percentage, how it is getting improved. Okay. So a lot of mechanical properties are related with this relative humidity and the moisture regain properties. So same fiber will act differently in different relative humidity conditions. That is the reason in the testing, when you are doing in a standard conditions, the accurate results we are getting. But such a fiber, when it is tested at a higher humidity zone or at higher temperature, the stress strain curve varies. So this relative humidity and regain percentage, that's why it is very, very important to control the properties of a textile fiber. Now it is very, very important when you are talking about the moisture, it is the hysteresis effect. So how it works? You can see that in this hysteresis curve that if a complete wet sample is there and if we try the moisture to evaporate from it, it takes long time. So it is time dependent behavior. Similarly, a dry sample when it is given or it is kept in a standard atmosphere, it slowly absorbs the moisture and reach to the equilibrium. So wet and dry, both samples are reaching the equilibrium conditions. Okay. So that is very, very important, that equilibrium conditions of moisture. So that is called the hysteresis effect. Now what is the conditioning of fibers? It is very, very important to understand the conditioning of fibers, because the textile material being hygroscopic normally, it attracts the moisture. Okay. So many of the processes, like as is shown in the spinning zone, it is also regulated by the condition of the fiber. So to adjust the moisture of the yarn and to improve the efficiency in the next process, the conditioning of fibers plays an important role. Now after processing, when the moisture level of the yarn would reach about 8.5% in case of cotton, strength and elongation can be increased greatly. So you can understand that how this strength and elongation behavior will be dependent upon the moisture level in the yarn. So that is important, or the importance of conditioning. Now we can see the static electricity generation in the textile process house, then the causes, problems and its elimination techniques, and how it generates static electricity. Let us see now. Now if you see this picture, you can see the charged material. So charged material, if it is a positively charged material, then positive ions will be there and it will attract the negative ion. Okay. And both cases, the positive and negative, and one is a negative plus positive. But if there are two ions are there which are different, that is plus and minus, it will attract. Okay. So both of them will attract each other. So that is the basic theory of the attraction of ion and the repulsion of this ion. So positive and negative charge will attract and both positive charges will repel each other. Now based on this, we can easily point out that similar charges repel one another. As we can see in the textile spinning area or the drafting zone area, how the ballooning formations is there in the yarn. Then difficulty in handling materials. If similar charges are generated, then very difficult to control the material. Then ballooning of a bundle of slivers, that is also important there. And cloth will not fold down neatly upon itself when it comes off a finishing machine, and so on. So that is the different kind of effects we are getting from the moisture. Now different other examples can be seen, like in the carding machines, in the spinning department. So here the charged bodies are attracted by an uncharged bodies. Due to this, charged fiber will stick to earth parts of the machine, happens particularly in the carding operations. So very difficult to separate out the fibers, because due to the static electricity generation, it will attract within themselves. So difficult to repel each other, the charged fibers. Now similar type of cases are also happening in other parts, like while passing over the guides due to this static electricity charge, roving process also experiencing more friction and thus breakage may occur. Due to the allocation or repulsion, roving cannot be wound onto the bobbin easily. So static electricity here plays an important role in this roving operations in the spinning. Now let us see the technique or how it has effect in the fabric bundle or the fabric roll. You can see that in these conditions that there are ballooning formations, how it is getting stopped by some sort of static string. Okay, so ballooning formations is getting inhibited. Now we can also see that how this can be improved now by an increase the humidity in the department. The resistance of material can be reduced, so the charge will move and static charge will be eliminated. So this is one of the ways by increasing the humidity. Then the spin finish is another way by which the humidity can be controlled. Man-made fiber spinning by using the anti-static agent or spin applicator. So this can be done in this effect. Similarly, the earthing also is there. So earthing process also will reduce the charging. So metallic machine parts static generation can be eliminated. So in the summary, we can see that humidity, how it is important. We have seen the absolute humidity, we have seen the relative humidity, specific humidity, and how the moisture regain and moisture content, okay, of textile fiber varies. And then finally we have seen the static electricity generation and the effect of humidity, and how humidity is important in textile area, especially when the yarn is passing or fiber is getting attenuated in different machines, and how the ballooning formation is there due to static electricity. And we have seen that how all things can be dependent upon humidity and how to reduce those humidities. So that's all, students. Thank you.